In this example, I'm going to use the graph to help solve the inequality f of x less than 0. So I just want you to remember that f of x really is nothing more than y, right? It's the output values. So where y is less than 0 is everything here where y is negative. In general, that would be anything below this x-axis. That's where f of x is less than 0. And I can see that that happens from here to here and from here on. Now, one other condition is I need to attend to here is that f of x has to be less than 0, not equal to it. So technically speaking, these should be parentheses here to say I'm not including those endpoints between 0 and 3, and I'm not going to include this endpoint 4, and then on to positive infinity. So that's where this solution comes from. From 0 to 3, the function is below the x-axis, and as well from 4 to infinity, the function is below the x-axis. And then for the next part, where we're asked to find f of x is greater than or equal to 0, again, that's saying where is y greater than or equal to 0, where is y positive and 0. So that would be these values here, where the function is above the y or the x-axis, above the x-axis. So I see that that happens from this x value and less. And I also see that it happens from here to here, that the graph of the function is actually above the x-axis. Now, here I need to attend to that this is a strict inequality. I'm sorry, not a strict inequality. It's a greater than or equal to, so it's including the endpoint. So I actually want to have square brackets on this one. So I'm going to include this square bracket and from negative infinity to that square bracket, and then this to this 3 to 4 as well. And so that's where you see this solution come from. And just one final note, notice that we use the y values to determine where the solution would be, but then when we state the solution, we state the x values as the solution there.